Right now, 38 million miles away, something impossible is happening. On a world where the sun blazes 10 times brighter than Earth, where noon temperatures could melt lead and midnight freezes hydrogen solid, a ghostly tail stretches across space for millions of miles. Not a comet's tail. This belongs to a planet that spins so strangely that the sun rises, sets, then rises again in the same day. A planet where ancient ice sits just meters away from molten rock. This is Mercury, and it's been hiding secrets that could rewrite everything we know about planetary formation. But here's the kicker, we've barely explored it. While Mars gets all the headlines with its rovers and helicopters, while Jupiter and Saturn steal the show with their spectacular moons, Mercury, our closest planetary neighbor, remains almost a complete mystery. Only 2 spacecraft have ever successfully reached it, and there's a reason for that. Getting to Mercury is like trying to land a paper airplane in a blast furnace while riding a roller coaster. It's so technically insane that NASA spent 30 years just figuring out how to get there without being incinerated or flung into the sun. But now we're finally cracking Mercury's secrets, and what we're finding is blowing scientists' minds. Welcome to the most extreme world in our solar system. Welcome to Mercury. Here's something that'll mess with your head. Mercury is smaller than Jupiter's moon Ganymede, yet it's the densest rocky planet in our solar system. Why? Because it's basically a giant iron cannonball wrapped in a thin shell of rock. Picture a planet where 70% of it is pure metal core. That's like if Earth's entire mantle and crust were stripped away, leaving just the molten iron heart. And that's essentially what Mercury is, a planetary core that survived some cosmic catastrophe that should have destroyed it completely. But Mercury's weirdness is just getting started. Standing on Mercury during sunrise, you'd witness something that would break your brain. The sunrise, then stops, then goes backward, then rises again. It's like watching cosmic clockwork malfunction. Except this insanity happens every single day. This happens because Mercury is gravitationally locked in what scientists call a 3-2 resonance. The planet spins exactly 3 times for every 2 trips around the sun. It's like a cosmic waltz gone wrong, creating the most bizarre sunrises in the solar system. Let me paint you a picture of what a day on Mercury actually looks like. You're standing on the planet's surface at dawn. The sun appears on the horizon. Not our familiar yellow sun, but a blazing white disk, nearly 3 times larger than what we see from Earth. As it rises, it's moving noticeably across the sky. Then, as it approaches what should be noon, something incredible happens. The sun slows down, stops, then reverses direction and actually sets again in the east, where it just rose from. But it's not done yet. After this brief eastern sunset, it rises again and continues its journey westward, finally setting in the west some 88 Earth days later. This cosmic dance happens because Mercury's orbital speed changes dramatically as it swings around the sun in its highly elliptical orbit. At perihelion, the closest approach to the sun, Mercury is racing through space at 35 miles per second. That orbital motion actually overtakes the planet's rotation, making the sun appear to go backward in the sky, and the temperature swings. Forget everything you know about weather. At noon, Mercury's surface hits 800 degrees Fahrenheit, hot enough to melt lead, zinc, and tin. But during its 88-day-long night, it plummets to negative 300 degrees. That's an 1100-degree temperature swing. For comparison, the most extreme temperature change ever recorded on Earth was about 200 degrees, and that was considered remarkable. But here's the thing that really broke scientists' minds. Mercury has water ice, lots of it. On the hottest planet in the solar system, there are literally billions of tons of water ice sitting in permanently shadowed craters at the poles. It's like finding snowmen in hell. The ice has been there for potentially billions of years, just chilling in the shadows, while a few miles away, rocks are melting. We're talking about craters where the temperature never rises above minus 300 degrees Fahrenheit, even though they're on a planet where other areas reach 800 degrees. These aren't small patches either. We're talking about ice deposits that could supply a human colony for thousands of years. And if that's not weird enough, Mercury is venting a tail into space. A tail, like a comet, except it's made of sodium atoms being blasted off the planet by solar wind. This tail stretches for millions of miles, nearly 10 times the distance from Earth to the Moon. If you could see sodium light with your naked eyes, Mercury would look like a bright comet streaking through space. But here's what makes this tail truly bizarre. It gets brighter not when Mercury is closest to the Sun, but 16 days after closest approach. Why? Because of something called Doppler shift. When Mercury is moving away from the Sun at maximum speed, the sunlight gets stretched just enough that sodium atoms in the tail can absorb and re-emit it more efficiently, making the whole tail glow brighter. The real mystery isn't what Mercury is, it's what Mercury used to be. Because everything we see suggests Mercury is the broken remnant of something much larger. The leading theory, Mercury was once a much bigger planet, maybe the size of Earth, but the Sun's intense radiation and solar wind gradually stripped away most of its outer layers over billions of years, leaving behind just the dense iron core we see today. Now, here's where things get really interesting, and by interesting, I mean absolutely insane. You'd think that getting to Mercury would be easy. After all, it's our closest planetary neighbor, right? Wrong. Mercury is the hardest planet to reach in our entire solar system. Harder than Pluto. Harder than Neptune. Here's why. When you launch a spacecraft from Earth toward the inner solar system, something terrifying happens. The Sun's gravity grabs hold of your spacecraft and starts dragging it inward at incredible speeds. By the time you reach Mercury's orbit, you're screaming through space at over 40 miles per second. Now try to imagine the problem. You need to slow down enough to be captured by Mercury's weak gravity, but you're flying so fast that Mercury can't catch you. It's like trying to catch a bullet with a butterfly net. Miss the braking maneuver by even a tiny amount, and congratulations, you've just created an artificial comet that's going to slam into the Sun. To put this in perspective, launching to Mars requires a velocity change of about 3.6 miles per second. Getting to Mercury, you need to change your velocity by nearly 17 miles per second. That's almost 5 times harder than getting to Mars, and Mars is often farther away than Mercury. This is why, despite being the closest planet to Earth on average, Mercury was visited by spacecraft for the first time only in 1974, 3 years after we'd already reached Mars, and 1 year after we'd reached Jupiter, which is 6 times farther away. That first mission, Mariner 10, could only manage 3 quick flybys. It took pictures of about half the planet and then said goodbye forever. The spacecraft used Venus's gravity to bend its path toward Mercury, but it could never slow down enough to stay. It just screamed past at thousands of miles per hour, snapped some photos, and kept going. For 30 years afterward, Mercury remained largely unexplored. Why? Because nobody could figure out how to actually get into orbit around it without carrying so much fuel that the spacecraft would be too heavy to launch. The fuel required for a direct mission to Mercury would weigh more than most entire spacecraft. Engineers calculated that a direct mission would require a rocket the size of a Saturn V, the monster that took us to the Moon, just to get a small probe into Mercury orbit. It was completely impractical. Then, in 1985, a brilliant orbital mechanics expert named Chen-Wan Yen cracked the code. Her solution was so crazy it was genius. Don't go straight to Mercury. Instead, take the scenic route, the really, really scenic route. Her plan called for a spacecraft to fly past Earth once, Venus twice, and Mercury 3 times, using each planet's gravity to gradually slow down. Each planetary flyby would shave off a little more velocity, like cosmic brakes. The total journey, 7 billion miles. That's like flying to Pluto and back. To reach the closest planet to Earth, it took NASA 20 years to build up the courage to try this insane plan. The mission was called MESSENGER, an acronym for Mercury Surface, Space Environment, Geochemistry, and Ranging. The name was perfect because, like its mythological namesake, this spacecraft would be humanity's messenger to the closest planet to the Sun. March 17, 2011, after a 6.5-year journey covering 7 billion miles, MESSENGER finally slipped into orbit around Mercury. and immediately started sending back data that blew every theory about planetary formation to smithereens. Remember how scientists expected Mercury to be a simple, boring, fried rock? Yeah, about that. First surprise, Mercury is covered in volatile elements, stuff like potassium, sulfur, and sodium that should have been cooked off billions of years ago. It's like finding butter that hasn't melted in an oven. This discovery single-handedly destroyed multiple theories about how planets form in the inner solar system. You have to understand how shocking this was. For decades, scientists assumed that Mercury was basically what would be left if you took Earth and cooked it at 800 degrees for 4 billion years. All the light elements should have been boiled away, leaving behind a concentrated ball of iron and heavy materials. Instead, Messenger found that Mercury's surface contains more sulfur than Venus, more potassium than Earth, and sodium levels that are off the charts. These are exactly the elements that should have been the first to evaporate. It would be like expecting to find ice cream in a furnace. Second surprise, Mercury has been geologically active much more recently than anyone thought. The planet is covered in strange formations called hollows, mysterious pits that appear to be forming even today, as volatile materials sublimate directly from solid to gas under the intense solar radiation. These hollows are unlike anything we've seen anywhere else in the solar system. They're shallow, irregularly shaped depressions with bright floors and halos. Some are just a few feet across, others stretch for miles, and they appear to be actively growing. On a planet that was supposed to be geologically dead for billions of years, we found features that are changing on human timescales. Scientists think these hollows form when volatile rich materials in Mercury's surface rocks heat up enough to vaporize directly into space. It's like the planet is slowly evaporating from the inside out, leaving behind these mysterious pockmarks. Third surprise, Mercury's magnetic field is bizarrely offset from the planet's center. On Earth, our magnetic field is generated by our spinning molten core, which sits roughly at the planet's center. Mercury's magnetic field generator seems to be shifted toward one side of the planet by hundreds of miles. Nobody knows why. This offset creates a lopsided magnetosphere, the magnetic bubble that protects a planet from solar wind. One side of Mercury gets much better protection than the other. It's as if the planet's magnetic shield has a giant hole in it. But perhaps the most important discovery was the detailed mapping of Mercury's gravitational field. By precisely tracking Messenger's orbit, scientists could measure tiny variations in Mercury's gravity that revealed the planet's internal structure. What they found was astounding. Mercury's core makes up 85% of the planet's radius. That's enormous. Earth's core is only about 55% of our planet's radius. This massive core confirms that Mercury really is the remnant of a much larger planet, something probably the intense solar wind and radiation pressure from the young sun stripped away most of Mercury's outer layers billions of years ago, leaving behind this concentrated iron ball. But the biggest surprise was what Messenger found at Mercury's poles. Not just water ice, but organic compounds, complex carbon molecules sitting in the permanently shadowed craters. On the planet closest to the Sun, we found the building blocks of life. These organic compounds are probably delivered by comets and asteroids, then preserved in the permanently cold crater floors. But their mere existence on Mercury suggests that the ingredients for life can survive even in the most extreme environments in our solar system. Messenger also discovered that Mercury once had extensive volcanic activity. The planet is covered with ancient lava flows that filled huge impact craters and created vast smooth plains. Some of these volcanic deposits are among the youngest features on the planet, suggesting that Mercury was geologically active much more recently than anyone expected. The volcanic activity itself tells a story of a planet under extreme stress. As Mercury's huge iron core cooled and contracted, it squeezed the overlying rock layers, creating the long cliff-like formations called lobata scarps that crisscross the planet's surface. These scarps show that Mercury has shrunk by about 4 miles in diameter since it formed, a massive amount of contraction that speaks to the ongoing evolution of this strange world. Messenger spent 4 years in orbit, 4 times longer than planned, taking over 270,000 photographs and mapping every square mile of Mercury's surface. When it finally ran out of fuel in 2015, scientists deliberately crashed it into Mercury's surface, where it created a new crater about 50 feet wide. Even in death, MESSENGER contributed to our understanding of Mercury by giving us data about what happens when objects hit the planet at high speed. Right now, as you're listening to this, another spacecraft is hurtling through the depths of space on its way to Mercury. It's called BepiColombo, named after Giuseppe BepiColombo, the Italian mathematician who figured out Mercury's strange 3-2 spin-orbit resonance, and it makes MESSENGER look like a toy. BepiColombo isn't just one spacecraft, it's two. The European Space Agency built one orbiter called the Mercury Planetary Orbiter to study Mercury's surface and interior in unprecedented detail. The Japanese built another called MIO, which means waterway in Japanese, to study Mercury's magnetic field and the way it interacts with solar wind. Together, they're going to answer questions that MESSENGER could only dream about. But getting there is still an absolute nightmare. BepiColombo launched in 2018 and won't arrive at Mercury until December 2025. That's a 7-year journey for a planet that's only 38 million miles away at its closest. The spacecraft has to fly past Earth once, Venus twice, and Mercury 6 times, using each flyby to gradually shed speed. The spacecraft is essentially 3 modules stacked together: the 2 science orbiters and a propulsion module that provides the thrust for course corrections during the long journey. This configuration means that most of the scientific instruments are blocked and can't operate normally until the spacecraft reaches Mercury and the modules separate. But even during these flybys, BepiColombo is already making discoveries. During its first close flyby of Mercury in October 2021, the spacecraft passed just 124 miles above the planet's surface and captured stunning images of craters, volcanic deposits, and the mysterious hollows that MESSENGER first discovered. One of the most remarkable things BepiColombo has done is capture the sound of flying past Mercury. Yes, sound in space. The spacecraft carries an accelerometer that detected vibrations as it passed through Mercury's magnetosphere and shadow. Scientists converted these vibrations to audio frequencies, allowing us to literally hear what it sounds like to fly past another planet. The sounds are haunting: a low rumble as the spacecraft enters Mercury's shadow, then a sharp change in tone as it emerges back into sunlight. There are also the mechanical sounds of the spacecraft itself, instruments moving into position, solar panels adjusting their angle. It's like listening to the heartbeat of space exploration. BepiColombo has also used its limited scientific capabilities during flybys to study Mercury's exosphere, the thin shell of atoms that surrounds the planet. The spacecraft detected calcium, magnesium, and other elements being blasted off Mercury's surface by solar wind, adding to our understanding of how the planet is slowly evaporating into space. When BepiColombo finally reaches Mercury in December 2025, the real work will begin. The spacecraft will split into its 2 component parts, with each orbiter taking a different path around the planet. For the first time, we'll have 2 spacecraft studying Mercury simultaneously from different perspectives, giving us a 3-dimensional view of how this bizarre world works. The European orbiter will create the most detailed maps ever made of Mercury's surface and interior structure. It carries instruments that can detect elements down to the parts per billion level, camera systems that can resolve features just a few feet across, and spectrometers that can identify minerals that MESSENGER could never detect. The Japanese orbiter will focus on Mercury's magnetic field and its interaction with the solar wind by studying how charged particles from the Sun interact with Mercury's lopsided magnetosphere. Scientists hope to understand not just Mercury, but how magnetic fields work on planets throughout the universe. BepiColombo might answer some of these questions when it arrives in 2025, but knowing Mercury, it'll probably just give us a whole new set of mysteries to solve. And that's the beauty of planetary exploration. Just when you think you understand a world, it surprises you. Mercury, our scorched, frozen, metallic, mysterious neighbor, is the perfect example of how the universe always has more secrets to reveal. The next time you see Mercury in the evening or morning sky, and you can, if you know when to look, remember, you're looking at one of the most extreme environments in our solar system, a world that challenges everything we thought we knew about planets, and a place that might hold the keys to understanding worlds we'll never visit, orbiting stars we'll never reach,